Okay, so let's take a look at another gas law problem. So take a look at the question in front of you. A sample of nitrogen gas. A sample of nitrogen occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at 95 degrees Celsius? So starting off, let's go ahead and identify P1, V1, and T1. So P1, V1, T1. P1 doesn't give us any information about that. V1 equals 250 milliliters. T1 is equal to 25 degrees Celsius. And then we go over and we take a look at P2, V2, and T2. Continuing to read through the problem, does not give us a P2, but we do show a change in temperature where it goes from 25 degrees Celsius to 95 degrees Celsius. Now, if you remember back in the notes, it stated that your temperature in Celsius should be converted to Kelvin. So what we'll do is we'll change the Celsius temperature to Kelvin by adding 273. 273 plus 25 equals 298 Kelvin. And 95 degrees plus 273 equals 368 Kelvin. So now we've converted our Celsius temperatures to Kelvin. So in the problem, it does not give us a pressure, so we can go ahead and assume that pressure is constant, so we can go ahead and take that variable away. The equation that we will use is V1 over T1 equals V2 over T2. So this equation shows a direct relationship between volume and temperature. So now we'll plug in these numbers to that equation. All right, so now that we have identified our given and the unknown, we're going to go ahead and plug these numbers into the equation. So you have V1, which is 250 milliliters, divided by 298 Kelvin, which will be equal to to V2 over 368 Kelvin. So your next step, we need to isolate the variable V2. So we're going to multiply both sides by 368 Kelvin. When we do that, your Kelvin will cancel. When we do that, the temperature will cancel. So now we're going to multiply 368 times 50 divided by 298. And that gives you a final answer of 309. Your units of Kelvin will cancel, which leaves you with a unit of milliliters. Your final answer, the second volume, is equal to 309 milliliters. And so what you can see as I plug this answer in as V2, when you look at this ratio 298 to 368, that is an increase in temperature, and because we're looking at a direct relationship between volume and temperature, we should also see that the volume would increase as well. An alternate way to work out this problem is to look at the ratio between the two temperatures and the ratio between the volume. Well, since we're solving for V2, we're going to look at the ratio between T1 and T2. Looking at the ratio between T1 and T2, so if I do 298 divided by 368, that will equal 0.81. All right, so that is the ratio between 298 and 368, the ratio between T1 and T2. So now we're going to look at the ratio, and we're going to use this number, and we will divide 250 by the ratio of 0.81. So 250 divided by 0.81 equals 309. And so that is an alternate way to work out this problem, remembering that your final unit should be in